All right, so welcome to the last topic of the year, essentially. We're skipping the last two chapters because we can. Which inference is which? So think back to day two when we talked about the W's who, what, where, when, why, how. The what specifically is what we are interested in here. So, what would an individual respondent say to the survey or to the experiment? So, we're thinking of experimental design here and going back to what is an individual responding. How is an individual responding? Are they responding with a yes or a no? Or some other categorical variable? Then we're in proportion territory. Side note, if there are multiple ways they could respond, like let's say math, science, English, social studies kind of thing, then we can do two things. We can either do what we did with Bernoulli trials, break it up into a math and not math, or we can go into chapter 26, and chi-squared is the name of the test there. But you can learn about that on your own. So that's if they would respond with a categorical variable, essentially. We're in proportion territory. If they were to respond with a number or a quantitative variable, then we're in means or t territory. The tricky part here is if an individual respondent is like a collection of people, like you're sending surveys out to schools and they're responding back to you, they can respond with a percentage. The percentage that they respond with, that is a quantitative variable because, like, your rows in the table are Greenwood High School 27%, Loyal High School 25%, Owen Withy High School 33%. Like, they're responding with a number, so it is a quantitative variable. Basically, is our summary statistic going to be a mean or is it going to be a proportion? That's basically the first question that we're asking. The second question is easier. Do we have one sample or do we have two samples? The biggest gotcha with this is obviously the paired samples that we just got done talking about. But that only really applies to quantitative data. There's a little bit of fuzziness when we're asked to compare one value to another. We need to know where both of those values came from, essentially. One of them is going to be a sample, but is the other one like an absolute value? Is it that the coin should be 50-50? Is it data from the census that we're comparing to, which should be exactly the population value? That would be a one sample. But in most cases, a different value that we're comparing to is going to be established by a study of some kind as well, and so that would be susceptible to variation and not 100% reliable. So we would want to use two samples. Finally, third question, are we doing an interval or are we doing a test? Basically, a test answers the question, is there a difference? While an interval answers the question, how large is the difference? You can use intervals to tell if there is a difference, right? If the proportion is supposed to be 50% and my interval is 55 to 65%, I don't think it's 50%. It gets a little tough when we're looking at one-sided intervals, one-sided tests, but not really too bad. Yeah. I'll put up some examples of me going through everything, and that will be this lesson.